Hello everyone. Uh, in this lecture, we are going to talk about the numerical integration. Numerical integration is used when the function is too complex to apply the algebraic analytic uh, integration, or the data is tabulated, means the data is measured by the sensor and is not come from a function as you see in the left side, right? So okay, for applying the numerical integrations, there are some methods like trapezoidal rule. Trapezoidal, as we know, first we discuss about the concepts of the integration. As we know, integration, if we see when we see this symbol, the integral symbol, integration of if if x dx x approach to from a to b, it means the area between the area between xd to xb, right, and fxa to fxb, this area considered as integration. When we talk about integral, this symbol you see, it means we are talking about the area below the curve, below the function, or below this figure, right? So based on that, if we apply, if we approximate it as a trapezoidal shape, okay, and we measure the area, let's say here is h, okay, so trapezoidal area measured like this, right? h over 2 a plus b, as you can see, right? Same concept. From this concept, we can measure the area of the approximation of the area below the curve of the function, right? Okay, so if we add up the trapezoid area, means we divide it to the smaller points. If I change it to the line would be better. If we divide it to the smaller points, right, means smaller segments, okay, smaller segments, we can have better approximation, means more increasing in order to increase the accuracy. And measure area of each segment, 1 segment, 2 segment, 3 segment, 4 segment, 5, for example. Okay, we will have more accuracy. After summation of the area of each section, we will have a formula of this, means area of segment 1, segment 2, segment 3, segment 4, segment 5 until n. If we apply the summation, we'll have the formula like this. Okay, so for better understanding, we solve this example. In this example, if x equal to 0.2 minus 2x2 plus 40x5, okay, if we only have 2 points, if we only have 2 points, a equal to 0 and b equal to x5, means only 2 points. So if only 2 points, the integral will be, we can use this formula to apply the integral. First substitute inside the fx, the function, to both point, Then we can apply to this formula, substitute this to this formula, and we can calculate the A. So if we want to have more points, for example, x 3 points, x0, x1 and x2, what we can do, if for example this point I know is 0, this point 0.8, right? So I will add another points between these two, which can be 0.4, right? These 2 points. So for the 0 is 0.2, the function, and the value of the function for the point 0.8 is 12.02. And for 0.4 we can measure that 0.2 plus minus 2 times 0.4 power 0.2 0.4 power, oh, I have to make it bigger. 0.4 power of 2 plus 40 times x power of 5 times is power of 5. Okay, use calculator. Minus 2 times 0.4 power of 2 plus 40 times 0.4, x is 0.4 times 5, this is equal to 0.28. 0.4, I make it bigger. Okay, 0.4 over 2, we make a bracket. If 0 is 0.2 plus 2 times fx1 0.2, 8 plus 12.02 equal to 2.56. Okay, so h actually is this step, for example 0, 0.4, 0.8. h in this case is this step of jumping. For example, between x1 and x2 the difference is 0.4. Between x2 and x1 the difference is 0.2. This means the step. For instance, here question asks us for 0.2. Okay, 0.2 first is 0, and okay, 0.2 plus 0.2 becomes 0.4, 0.4 plus 0.2 becomes 0.6, and 0.8, the last one. Okay, after substituting, this one will be 0.2, this one is 0.13, this one 0.4, 0.28. If we substitute same as this as I did it for you, instead of 0.4 4, you substitute 0.6 this time, will be 2.59, and for the last one will be 12.02. Okay, here we will have, this time h is 0.2, right, over 2 plus substitute all 0.2 plus 2 times 0.13 plus 2 times 0.25 plus 2 times 2.59 plus 12.02. As you can see, for when you want to apply or use this method, these two, you have 2 points, right, in the middle one, in this tree, I mean, in the middle, see, in the middle. The two last terms, this one and this one, there is no coefficient 2. There is no coefficient 2, only in the middle half. Okay? Okay. After substituting, I give you the final answer. The final answer will be 1.82. This is the answer. Okay. This formula was for trapezoidal rule. Okay, trapezoidal rule formulation. So we have formula number 1. Okay, another method is Simpson 1/3 rule. Okay, Simpson 1/3 rule can be driven by the integration of forward Newton-Georgi interpolating polynomial. Okay, you can see the mathematically how they reach the formula, which is these. You can do it by yourself, but finally the formula is, as you can see, h/3 in the bracket fx plus 4 times fx1 plus fx2. Mid one have 4. The other side one means the beginning and end of interval or the range doesn't have any coefficient. The coefficient means 1, doesn't have means 1. But the mid one, the coefficient is 4. Okay, same question. Okay, in the example 2, the function is the same and the interval is same. Okay, so we have 2 points. How the h calculated like this, h equal to end of the interval minus beginning of the interval 0, this is 0, this is 0 over n. What is n? The number of the segments. The question asks us. The number of segments is 2, so here we put 2. So the answer will be 0.4. Okay, this h, I'm talking about this h. This is how we calculate h. Okay, so we have 3 points, right? We have 3 points here. A start is 0. Okay, 0 plus 0.4, 0.8, the last one. Okay, after substitution, inside each points inside the function, we will have for 0.2 here, for the x1 we will have already calculated 0.828 and should be 12.02, right? Okay, so only substitution in here and we will have 1.78 after substitution. Only substitute each value. You have fx0 here, 0 0.2, 0 0.28, and 12.02. Okay, as you can see, only the mid one have 4. Okay, so what is this? This is 1 over 3. Simpson's 1 over 3. Okay, but what if we have multiple points? Still Simpson 1 over 3. What we have if multiple points means more points? In that case, h over 2.3 is still the same. In the bracket, the difference is the mid one, the first, each of them, for example, first one, this is 10.0, this is 10.1, have 4, number 2 have 2, again 4, again 2, again 4, again 2, right? So the odd one have 4, the even one have 2. So over have 4, even one have 2. Okay, so as you can see, and the first and the last one doesn't have any coefficient, means the coefficient is 1. The second terms, the coefficient is 4. Third one 1. Number 4 again, coefficient is 4. See, 4 2 4 2 4 2, like this. This is the pattern. Okay, question asks us for 4 segments, n equal to 4. So as you can see below, we put 4. Begin end of interval minus first of interval over the number of segments. It means how I want to manage the points, like this. A 0 0 plus 0 0.2, 0 0.2 plus 0 0.2, sorry, 0 0.2 will be 0 0.4, right? 0 0.4 plus 0 0.2 will be 0 0.6, right? 0 0.6 plus 0 0.2 will be 0 0.8, right? So same, we substitute each point inside its function mentioned here, and then substitute in this formula. Okay. Simpson's another rule, 3.8. After applying in the proving in the mathematical way, we'll have this formula. This is the final formula that we need. This is what we need. 3.8 h. 3.8 h. As you can see, in the middle we have the coefficient 3 fx1 plus 3 fx2, the last beginning and end of the interval. We don't have coefficient, we don't have means 1 times 1 times. Okay, multiple applications. As you can see, if you have more points, means more than 2, or it means n equal more than 3, means n equal to 4 or 5, we can use this formula. Okay, example number 4. What happened? Example number 3. Already done. Example number 4. So, in example number 4, Example number 4. First is A. Ask the normal 3.8. Normal 3.8, I mean we need 4 points with the h of 0.26. How we calculate h? We need n equal to 3, right, for 3.8. As you can see in the formula, we need x1, x2 and x3, right? x1, x2 and x3 means minimum 4 points. So in that case, n equal to 3 means 3 steps, 1 2 3, 3 segments. Where segments is, if it is just a curve, 1 2 3 4, 1 2 3, 3 segments if this is the x-axis and y-axis. Okay, again 0. The first one will be 0. Will be 0. The other one will be 0.0 plus 0.26 equal to 0.26, right? So this will be 0.26 plus 0.26 will be 0.53, and the last one is 0.8. So I delete this because I don't have enough place. Okay. So each should be substituted in the function. After substitution, we will have 0.2, 0.15, 1.48. I just substituted input each point in the function mentioned in here, and I got this value, right? So only simply substitute in this formula. This is 3h over 8, Simpson's rule. Okay, the question B, asks for 6 segments. If 6 segment, we have to apply multiple application Simpson. So if we apply multiple application Simpson using this formula, okay, so we will get, if we put 6, right, n equal 6 segment means fx0 plus fx6, point number 6, okay, plus 3 f1 f2 until f5, f1 f2 f4 f5 plus n minus 3, 6 minus 3, f3, f3 times 2, f3 times 2. Okay, based on this formula, we will get this. If we substitute n in here, n equal to 6, f6, fx0 plus f6, fx6, this one, these two, okay, 3 times, back to formula, 3 times x1, x2, x1, x2, x4 x5, as you can see, x2 x5, but the terms have x3, this one x3 times 2 should be times 2, as you can see in here. Okay, for the h also is as we discussed before, in the n segments is, in this case, is 6 segments. So this is, we apply the formula and we got the step of 0.1. Okay, if we apply the step of 0.1, we will have, as you can see, oh, here is mentioned the main formula. How to use this? I think we discussed here, right? So point, for example, here was 0.26, beginning was 0, right? 0 plus 0.26, 0.26 plus 0.26 will be 53. 53 plus 0.26 become 8, 0.8. Here also is the same, 0, 0.28, right? So second one will be 0.133. Okay, first one will be 0 plus 2 times 0.13, right? 0.3 times 0.13, 0 plus 4 times 0.13, 0 plus 5 times 0.13. Okay, this time I use this formula. Right? Will be okay. After calculation of each x, then substitute in the function which is here. Okay, and you can apply in this formula. The point in this formula means 3.8 multiple here, multiple of Simpson's 3.8 rule, that the term has x3, this one, x3 is this one, this point. Okay, you should put 0. You should put 2 as a coefficient. End and beginning, the coefficient is 1 and the rest is 3. Okay. Okay. 10.6 is using the MATLAB. We can use the MATLAB. I think last week I showed you for numerical in the online class, numerical differentiation. I show you how to use MATLAB. You just use them in the MATLAB. This is the function. And this is the formula. Quad. File name of the m function. Okay, I think that's all. MATLAB, you can try. If in the tutorial you have to use MATLAB, there I will show you. It's written here. You can try, or you can search by yourself. But also in because in final exam we don't use the MATLAB, of course. So if in the tutorial we are going to use MATLAB, I will show you there. Okay, that's all. At the end we can do one conclusion or summary that what we said. In this lecture we talk about numerical integration, as we know from the concept of integral, which is the area below the curve of the function in the specific interval. For example, interval from xa to xb equal to area, right? If we simplify the area to trapezoidal shape with the area of applying the formula of the area of the trapezoidal, we can approximate the integral with this formula, right? With the area of the simplified shape. Okay, if we divide this to different sections, means to the more sections, n sections for instance, and we expand the formula, we expand the area, means we expand with sum of each section, sum of the area, we'll reach this formula. With applying this formula, in example 1, we found out the numerical integral of this function using what? Using trapezoidal rule. Okay. Another method is Simpson's 1/3 rule that we already studied. This is the formula of finding the h, and we have this formula for, we studied this formula for Simpson's 1/3 rule, which is, as you can see, we solved one example. Okay, we calculate by applying in h, which is our step in this case. So x0 and x2 is the beginning and end of our interval, and 0.4 is a step, right? We study also multiple applications of Simpson's 1/3 rule, means we have multiple points, right? We can also we study Simpson's 3.8 rule, which was the formula, as you can see, 3.8h fx plus 3 f1 3 f2 3 f3. So and we study multiple we study multiple applications of Simpson's 3.8 rule, and we solve one example for it. Okay, that was all. Okay, thank you for watching. See you for the next week.